afternoon. I'm going to present about classification and components of HPC clusters. So, what is high performance computing? High performance computing refers to the ability to process and compute extremely large amounts of data in a very short time. Instead of relying on a single machine, HPC uses multiple systems working together in parallel. This allows us to solve problems that would otherwise take months or even years on a normal computers. So, what is an HPC cluster? An HPC cluster is essential of a collection of interconnected computers called nodes that works together as one powerful system. Each node performs a portion of overall computation and they communicate through high speed and low latency network. This enables tasks to be divided and executed in parallel, significantly reducing computational time. So, why do we need HPC? HPC is necessary in fields where datasets are massive and simulation require immense processing power. Examples including weather forecasting, molecular biology, aerospace engineering, financial modeling, climate research, artificial intelligence, and large scale data analytics. Without HPC, many of the advanced technology we rely on today would not be possible. So, core components of an HPC cluster. Every HPC cluster is built using four major components. First, compute nodes, which performs an actual calculation. Second, high speed networking, which allows the nodes to communicate with minimal delay. Third, the storage system that can handle enormous input and output operations. And finally, the management infrastructure, which includes job schedulers and head nodes and monitoring tools. So, computing nodes. So, computing nodes are the heart of an HPC cluster. They usually contain multi-core CPU systems and sometimes GPU for accelerating tasks like AI machine learning. These nodes carry out heavy computational workloads assigned by the user or scheduler. Some clusters also include specialized nodes like GPU nodes and accelerator nodes for specific types of applications. So, head node. These nodes are so-called the login or master node is the entry point for users. It is responsible for a job scheduling, resource allocations, and cluster management. Users do not run their actual computational on the nodes. Instead, the head node dispatches jobs to compute nodes based on available resources. So, data transfer nodes and fat nodes. So, data transfer nodes allows for efficient movement of large data sets between storage and compute nodes. They ensure that data heavy workloads do not congest the main network. Fat nodes are another specialized types of node. They contain extremely large amounts of RAM, sometimes more than 1 terabyte, and are used for memory intensive applications such as graph processing or genome analytics. So, SMP architecture. SMP stands for symmetric multiprocessing. In SMP system, all processors can share the same memory and have equal access to it. This architecture is easy to program and ideal for sharing memory applications. However, SMP does not scale well. After a certain number of processors, memory becomes a bottleneck, limiting the system performance. So, MPP architecture. MPP stands for Massive Parallel Processing. In this architecture, each processor or node has its own local memory. Nodes communicate using fast networking and typically use the MPI communication standard. MPP system can scale to thousands or even tens of thousands of nodes. This makes them extremely powerful and ideal for modern scientific simulation and AI workload. So high availability clusters. High availability clusters are designed to provide continuous service even if one node fails. If the primary node experiences an issue, the backup node automatically takes over. The kind of setup is essentially in areas such as finance, healthcare, cloud service, and mission critical enterprises. Systems where downtime cannot be tolerated. Networks in HPC. Networks plays a crucial role in determining performance of an HPC cluster. Most clusters use specialized interconnects such as InfiniBand and HPC Slingshot. These offer extremely low latency and very high bandwidth, which are essentially essential for fast communication node and between nodes. Slow networking can drastically reduce the speed of the entire cluster. So, communication model MPI or message passing interface, the mostly widely used communication model in HPC. It allows different processors running on different nodes to exchange data efficiency. MPI, provides synchronization, communication protocols, and message handling, which makes it ideal for distributed memory architecture like MPP. Real world applications HPC clusters are used for a wide variety of real world applications. Climate modeling uses thousands of nodes to simulate global weather patterns, genomics using HPC to process DNA sequences for medical discoveries. Engineering fields rely on HPC for simulations such as crash tests and fluid dynamics. Finally, artificial intelligence training using GPU accelerator nodes to train neural network efficiency. So, in HPC clusters are critical for solving today's most complex computational problems. Understanding the components such as compute nodes, network, storage, and management systems, and knowing the difference between SMP and MPP architecture helps us appreciate the design behind these powerful systems.